And I will also say that this documentation, just like Jason was talking about a moment ago, it's been refined over time, and it really doesn't contain any more information than is necessary. I mean, sometimes you'll come into documentation and it's documentation, on page 17, and this documentation is really geared towards getting you what you need to know to get up and functioning, but not anything, no additional
No
information.
excessive, confusing nonsense.
No background theory. No, here's you
Yeah,
have to have read this chapter before I mean, it's very concise.
yeah. It's sort of like the best of. May not be exactly what you need, but I guarantee you, most of these examples, you can work from it and get where you need easily.
Yeah.
So the last thing before we start is I want people to be aware. This is sort of like what Jason was just saying. I went back when I started here in Corona. There were not this many physics joints, but recently I was helping somebody and I couldn't remember. I never remember this stuff, so I look in the documentation and I was like, "Are you kidding me? I mean, look at all these new joints." One that I found really interesting was there was a joint. Where is it? Now I'm not going to be able to find it. A guy I was working with was trying to draw a shape, and there was this joint here, or maybe it wasn't a joint, but a physics body. Yeah, I think I'm thinking of the physics body now. Here it is. Multi-element, no. Polygon, rectangle, offset, edge, the chain. So a new body type, and I was like, wow, that's really exciting. My point here is go back to the docs, check it out. Dollars to donuts. Oh, if you don't click on the wrong button like I just did. Dollars to donuts. You are going to find something new that you haven't seen before.
Yeah.
And I just messed up my documentation. I don't know what I just did to my browser, but it's closed up.
No, another cool example is, I mean, when I discovered content to local and local to content, which I think was only introduced in the last 18 months or so, it was like, oh my, this simplifies. I had my own sort of hacky workarounds to get those values when I needed them. They're just awesome, and it was something I discovered just browsing at random.
So it is, in fact, all good stuff, and there are a lot of features out there, obviously not announced, but useful to us. So today we're going to go through some examples. We're going to get started talking about two kinds of joints. One kind that is actually crucial to the design, and the other one that I use merely to to provide better feedback. So the two joints that we're going to talk about today are the pivot joint and the weld joint.
And just for anybody who's kind of new to the whole idea of joints, it sounds fairly self-explanatory, but what exactly are we talking about?
Okay, so a pivot joint, in any of these joints, a joint at all is a physics, not an object, but a structure in a sense that allows us to link two or more objects to each other. As your shoulder is a joint for your bicep, connecting it to your clavicle, is that right?
I don't know.
As your shoulder joint connects your arm basically to your shoulder, joints themselves can be used to connect two or more objects to each other. And there are a variety of different kinds of joints. Let's go back to the list. There's a pivot joint. A pivot joint allows one object to be connected to another object and to rotate freely around that joint. In other words, once connected, object B is allowed to rotate, pivot around the joint.
So maybe like maybe like an axle or something like that, or
like an axle, very much like an axle.
Okay.
Additionally, pivot joints can have no motor, which means that they're allowed to pivot 100%. There's no limitation. There's no power in a sense. It's not turning. Or you can set a limit, which says the pivot joint's only allowed to turn between, say, 50 degrees and 90 degrees, and that's the range it's allowed to pivot around, and then it's restricted after that. It's stopped. Pivot joints can have a motor in a sense, and what this means is that when enabled, it has a certain amount of torque, and I'll show this to you, and it actually rotates the joint, which then rotates the object that is mounted to that joint. So let me go back to the picture. B is mounted to A. It's a little bit hard to see. Right here in the center on this anchor or pivot joint. And if this were a motor pivot joint, what would be occurring is that the pivot joint would be turning in one direction or the other, and B would be forced to rotate with that pivot. In addition, we have distance joints, which is the job of a distance joint is basically to keep two objects linked to each other, but at a certain distance from each other. Piston joints, I'm not going to go into all of these today because they really require a more detailed coverage than what I can tell you, but you can certainly read through them. Charles I think he's exploded in the background there. So the only other joint we're talking about today is the weld joint. Now a weld joint is exactly like a pivot joint, except it's not allowed to rotate. Weld, as it implies, basically says object B is connected to object A, and if object A moves, object B moves. If object B moves, object A moves.
Kind of like the old Roadrunner cartoons, where he throws the anvil off the cliff and he's tied to it with a rope and it jerks him off down into the ravine.
Exactly, except in this case, the rope would be a rigid connection. I see what you're saying. I just don't want people to get confused.
Oh, so it is different. It's not a piece of string. It's an actual.
Right. It's not flexible in the sense that it's not allowed to. The distance between A and B is always maintained. The angle between A and B is always maintained. So if A rotates, B will be forced to rotate around this axis along this arm. Okay. So I'm going to show you a demo. Some demos of things that we're not going to get to talk about them all today, but you're going to get the code after the show, just to show you some of the things that you can do just with a weld joint, or I'm sorry, just with a pivot joint. There are weld joints here, but they're not actually used for anything in the demos as far as like physicality. They're purely used so I can give better feedback to show you something. I'll explain in a moment. So we start this with the simple joint, which is just this arm here is attached to the block in the middle, and as I drag the green part, in all of these samples, if it's green, you can touch it or click on it and drag it. Now, this center box here is a static body, which means that it's not allowed to move, so I can drag on it, it's not going to do anything. However, you can change the code and make it dynamic if you wish. Another thing you're going to see in all of these demos is they have a button, one or more buttons in the upper right corner. So the first one you'll often see says gravity. It's a toggle button. If I click it, it turns on gravity for the scene, and now you can see how gravity affects basically this arm connected to this static object around this pivot joint right here where the gray circle is. You can turn it off, and now it's free running again.